We'll discuss the topic of speed control of motors, which is very important topic from industrial point of view. We will discuss the motor types DC and AC in detail in separate electrical trainings. For the time being, we will mainly focus on the speed control of these two types of motors. So first of all, we'll start with the types of motors. In motors, we have two types: DC motors and AC motors. And DC motors are further classified into brushed and brushless. Brushed motors are further classified into series motor, shunt motor, and compound motor. Further, in brushless, we have the stepper motor and reluctance motor. These complete our DC motors classification. For AC motors, we have two types: synchronous motors and asynchronous motors. And in asynchronous, we have the induction motor, which is further classified into squirrel cage and wound rotor. Again, we will discuss these types in electrical machines and electrical system training program. For the timing, we will only discuss the speed control of motors. So first we will talk about the DC motors. In DC motors, this is the simple diagram where we have the DC supply, and we have here our commutator segment, which keeps the current flowing in the same direction. So when the current flows through this conductor present in the magnetic field, a force acts on these two sides. So these opposite forces form a couple or a torque on the motor, and the motor starts rotating. Now we can clearly see that the speed would then only depend upon the voltage, the DC supply source, what DC supply source we are giving to the motor. So this is the basic this would be the basic concept of the DC motor speed control. If we give the full DC rated voltage to the motor, we will get the full speed, and if we give less DC voltage, we will get less speed than the rated speed. So this is the basic here it is explained that the movement principle of the Fleming's left hand rule, how the DC motor works. We greatly encounter the servo motors in field. Servo motor is basically a simple DC motor with the external position control feedback mechanism. That is, it has external feedback mechanism of its position control. It uses the PWM signal, which is pulse width modulation, at its input to control the position of its shaft. So PWM signal is the basics of the speed control of DC motor. So further, I have mentioned the various common industrial applications for the DC servo motors in robotics, in conveyor belts, in cameras, autofocus, in robotic vehicle, solar trapping system, metal cutting and metal forming machines, antenna positioning, woodworking, printing, and automatic door openers. So now we come to the speed control principle, which is the pulse width modulation. So if we increase the pulse, we are increasing the DC voltage, average DC voltage level, and we are increasing the speed. So this is mentioned as the duty cycle. Which is equal to, this equation is T on over T on plus T off. The time, how much time your square wave pulse remains on. On means full volt, 12 volt. So here we can see that the duty cycle will be 75%, and here it is only 25%. So here we will be getting only 3 volts, and with 75% we will be getting 9 volts. So by varying the pulse width, we can control the DC average voltage to the motor, and hence the speed of the motor. So here it is also mentioned a 50% duty cycle, 75% and 25% duty cycles. So this completes our basic understanding of how the speed of a DC motor can be controlled. This can be controlled by pulse width modulation, and in pulse width modulation, the term we have is the duty cycle. So if we increase the duty cycle, we would increase the speed of the motor, and if we decrease the duty cycle, we would decrease the speed of the DC motor. After the DC motor, we will discuss AC motor. Thank you very much for listening.